Okay, good. So, Mark Wilson, I work for a UK-based organisation called RSM Partners. We have a foray into the US. We've recruited a reprobate to run our US business. He's in the audience. I won't point him out, but he's sat there. To my left is my colleague Ray Overby. So between the two of us, we're going to cover for the next hour. You're going to have to put it with me for the majority of this, unfortunately. So, quick intro slide. My official job title is Technical Director. Miracle Worker is more what it's like. We do have another nickname for me back in the office, CCBW. Anybody know what CCBW means? Chief Cook and Bottle Washer. Yeah? So I get to do everything, from emptying the bins to opening the doors to locking the doors to everything. I've been doing mainframe stuff since 1980, the year the film was released, Terminator. I started as a trainee operator, senior operator, senior operator, shift leader, ops analyst, systems programmers. Now I just talk about this stuff. I actually don't really do any proper work these days. So I look after the technical team, 85 people in the team, and literally all we do is mainframe stuff. So I've got 85 systems programmers come security consultants, come real pains in the backside type individuals, some old, some young, okay? Ray, on the other hand, because Ray's going to do his little slide here, so he's going to come and stand up next to me here and do this. No, I'm going to do it for him, okay? Ray has been coding since he was 14 years of age, then started really coding in 1984, so he's the junior member of the team, okay? And seriously, Ray is the mainframe vulnerability expert. This is what Ray does all of the time, okay? He likes to code. Doesn't matter what kind of code, he likes to code. Now, two things I am not aware of here. I had to research what a Jefferson nickel was, okay, or is. Ray collects them, okay, much to the disappointment of his wife, because I think their life savings is now invested in Jefferson nickels or something to that. And then he likes trout fishing, okay, and that's all we've got to do by way of an introduction. Happy to take questions as we go, okay? So, how well do you think your mainframe's secured? Do you think it's secured really, really well? Yes? No? Don't know? Ever had it tested? Absolutely. Do you believe you've locked down your mainframe system from a RACF, ACF2, top secret perspective? We have some people who think all our process and procedures are perfect. If anybody came knocking on our door, by way of a penetration test or a security assessment, we know that they were knocking at our door. Who thinks that they've got that really locked down, feeling really secure? Should you be? Do you think it's absolutely rock solid? Well, unfortunately, not unfortunately, the way this stuff works, the foundation of everything we do by way of ESM controls, RACF, ACF2 or top secret, the foundation is integrity. Without integrity, we have no security, okay? What about if you have an integrity vulnerability on your system, and I tell you with a Rex exec you could bypass all of your RACF, ACF2 and top secret controls, and you could do it with 15 lines of Rex code, if you have a vulnerability. So don't you think it'd be an idea to know if you've got any vulnerabilities? So how many people actively check their mainframe for mainframe code vulnerabilities? Any takers? No. Damn. So the foundation of all of this stuff is integrity. ZOS, IBM, have an integrity statement. Who's read it? Who's memorised it? Who could recite it word for word now if I asked them up on the stage? Okay. It's been around a while. It's been around longer than Ray and I. It's probably been around longer than most people in the room here by way of not an age, an experience perspective. Okay. So, 1973. Okay. IBM's first version of the integrity statement, 1973. You'd think we'd have this done by now and sorted and down pat and really, really, locked down. The cornerstone of integrity for us in most instances is the controls we place around APF authorization. Who thinks they've got all of their APF authorized libraries and the things that can affect APF authorized libraries locked down and absolutely protected? Who knows the difference between a setprog command and a setprog command? Yeah? Because there's two versions of it. Have you got them locked down properly? Yeah? There's the T-space setprog and there's the setprog command. Yeah? Two different security profiles required, or a very generic one that covers both of them. Yeah? Have we got it really locked down? It's not quite that simple. There's other stuff. Yeah? There's obviously the linked list, the LPA list, the program properties tables. We've got some exits that run authorized, and we've got SVCs. Yeah? When we say SVCs, we talk about SVCs and kind of Uber SVCs, PC routines. Yeah? So we cover that all under the same kind of guise. The interesting thing for me from a mainframe perspective is that normal working operation for a mainframe program is known as problem state. And that kind of just seems a little backward to me. It's working well because it's in problem state. Okay? The opposite of that is supervisor state. So mainframe programs are in two states, or can be in two states: problem state, supervisor state. And the real controller here for this is the Z hardware. Okay? So it's the hardware that says you're a problem state program, you can only issue problem state instructions. And that's a subset of all of the instructions that are available to the hardware. That's it. What this means, if I've got a program in problem state, I can stop a program, or the hardware will stop a program accessing those supervisor state instructions. Yeah? We do it, now we say we generically, IBM do it for us by using this PSW, the program status word. Okay? That keeps track of a state, yeah, of the running program. So we use the PSW key, the key mask, the problem state bit, and if the problem state bit is on, you cannot execute supervisor state instructions. That's the control. So it's the program and the hardware working together, the operating system, the hardware working together. So these are the controls we've got. So what we need to make sure is that anybody who writes code that runs on our mainframe in a potentially system state actually follows that integrity, all the rules in the integrity statement. Because if you get it wrong, people who like to do bad stuff to computers, because remember too, the bad folks, the mainframe is just another computer. Yeah? Do they need to understand APF, linked list? A little. Where are they probably going to come and try and attack us? Unix system services, FTP, SSH. But if they want to do bad stuff to your mainframe, they're going to want to elevate their privileges to the point they can get to supervisor state, key 0, and do stuff. Yeah? That's what they want. So we start talking about things like secure coding. And doing it right is not simple, but it's not difficult, okay, if you follow the rules. If you don't follow the rules, you can seriously shoot yourself in the foot with this, okay? And you come up with this phrase that says code responsibility, yeah, or code responsibly, yeah? So when you find a problem like this and you talk to a vendor and they say, working as designed, and you say to them, yes, but it's not secure, they say, we don't care. It's working as designed. That's not coding responsibly. Because if people get this wrong and write the code wrong, yeah, you can be in a position where somebody like Ray, Lou, Chad, one or two others in the room could have their way with your mainframe, have all your data, burn everything in your mainframe data center. We can just heat the box up to a point it'd explode. Yeah? Absolutely doable, with this level of knowledge and experience. Yeah? So, how do you do this right? Education, okay? IBM have a secure coding team at Poughkeepsie who you can talk to. There's an actual website you can go to, a whole bunch of YouTube channel, whole bunch of YouTube-like videos, okay? The Knights of IBM Z, okay? And they explain some of this out there, how to do this, how to pass parameters from one program to the other, how to allocate storage, how to actually pass parameters between different pieces of code. But there's one thing we've got to remember with this, yeah? We're not talking about your application code here. We're not talking about your Kix applications or your IMS applications or your batch applications. We're talking about I nearly slipped into American mode then. ZOS, okay? ZOS, Kix, IMS, DB2, any ISV code you get from any of the vendors, BMC, CompuWare, CA, any of them, yeah, that supply you system type code. That might be exit code, anything that runs APF authorized, could be an SVC, could be a PC routine. That's what we're talking about here, that type of code. So when people start saying to you, I want you to do a vulnerability scan of my application, that really doesn't have a great deal of merit in this space. It's not what we typically do. We're looking at the infrastructure, the integrity of the infrastructure. Okay? Google is absolutely your friend here, because there is so much stuff out there and educational videos and documentation that tells you how to do this stuff properly. Because if it goes wrong, yeah, it kind of gets really, really interesting as to, you know, what you can actually do to a system, okay? If you put, anybody understand CVSS scoring? Okay. This, yes, thank you, Chad. Okay. This is a way that the non-mainframe world has traditionally, categorized, issues, whether they be code issues or configuration issues for security vulnerabilities. And we're doing that with mainframe stuff today, and Ray's going to mention a little bit about it. But if you get something that comes across your desk that says CVSS 10, and the rating is 0 to 10, do you think 10's bad? Yeah? Some of the stuff we're going to have a look at here is probably in 11. Okay? So, because let's suppose you have a piece of code that's been supplied by a vendor, an ISV, or written by one of your in-house technical teams. How many assembler coders in the room? Who's written SVC and PC routine code in their life? Who's been back and checked it recently and did I adhere to all the rules and, or tested it? Because this is what we're looking for, We're looking for issues here. What about if that code has a vulnerability? Oh, look, what happened to my picture? There's some more text behind there that says, what about if there's a vulnerability there that the developer is not aware of? And somebody comes along, and spots that code defect and then realizes they can exploit it. Okay? And there's a whole bunch of different things you can do with this. Like, let's call this SVC, and the first thing it does as you enter the SVC is pops you into supervisor state key 0. Can somebody tell me what I cannot do to your mainframe at this moment in time? So my address space is now key 0 supervisor state. SVC 34, issue an MVS command. Anybody ever used the quies command in an MVS environment or a ZOS environment? Yeah? You know when you go up to your PC and you go Control-Alt-Delete standby? Yeah? The MVS command quies does that to your mainframe. It literally hard stops it at that point. The trick is, how do you recover from it? Who remembers how to recover from a quies command? At 4 o'clock in the morning, when the IT director's on your shoulder saying, Mark, when is our mainframe coming up? Or 10 o'clock in the morning, when all your online systems have now stalled and there's no ATM transaction, there's no online banking, how do you recover from a quies command? Go to the HMC, find the LPAR, right-click on it, go to operations and do PSW restart. You're all going to remember that now, aren't you? Okay? Because That's where you get to with some of this stuff, yeah? I mean, you are literally sat atop the physical box, yeah? Knees dangling over the edge of it, yeah? You are in complete control. You can do anything you want. I can have all your data. I can destroy all your data. I can issue any instruction I want to that mainframe. So you're only really limited by your coding skills, your imagination, and what you find on Google. That's really all that, yeah, once you're in this position. And there is code out there that's being found to be like that. So you literally can bypass all of those ZOS controls. But what's more interesting, you can also bypass and disable all the logging and monitoring. And you can do this in stealth mode. So we might go out and do some of this pen testing stuff, and we might have had some fun with our clients over the years. I wouldn't definitively say, yes, we have, but we may have done. But there was a moment in time where we were on site with a client, absolutely in control of their system, because we'd got access to a poorly written SVC. And it was a RACF environment, so the first thing we did is flipped all the bits in our ACEE to give us RACF System Special, Operations and Auditor, and then started issuing commands to look at things in the RACF database. But we didn't write anything back to the RACF database. Now, we were doing a pen test and we thought we were being closely watched. So what we decided to do, or no, I'm not going to blame Chad, but what Chad decided to do, okay, was actually issue a command to write something to the RACF database that caused an SMF record to be generated. We were sat in a room that was probably the size of this room here, and the guy's head came through the door 30 seconds before his feet actually did, okay? Because he couldn't wait to get in the room. We think he was sat there pressing enter, yeah, watching everything we did. And we were at this for 5 days, and we'd been on the system probably in this state for about 8 hours, 12 hours. So we'd had our way with the system, we'd got all the data, done everything we wanted. But the minute we wrote something to the RACF database, they saw it. But of course, yeah, we didn't have to do that. And that's the beauty or the downside of this. We can turn all that logging and monitoring off so you don't see anything. So you need to start thinking about how you're going to protect yourself, yeah? Yeah? Encrypt all your mainframe data. There's a quote that goes around sometimes when you come to these events from, yeah, 1 or 2 folks. What's the difference between pervasive encryption and ransomware? Who knows what ransomware is? Yeah? Somebody who maliciously, yeah, encrypts all your code. Who knows what pervasive encryption is? Yeah? What's the difference between the two? Who has the keys? That's it. The only difference between ransomware and pervasive encryption is who has the keys. Okay? Hopefully you've got your keys. But if I get your keys, which I probably could if I can get key 0 supervisor state, yeah, game's over. So as I said, you're only really limited by your imagination. So at this point, I had a choice. Do I risk VPN into my system back in the UK and doing a real-time hack of a mainframe? Or do I chicken out and record this? So I recorded it, okay? So there's like a 2-minute video here, and I have now got to suffer the presenter's worst nightmare, and that's listen to your own voice, okay? So if all this works, I'm going to run a video for a couple of minutes, okay? And then there's a couple of little slides, and then what we're going to do is we're going to hand over to Ray, because Ray's braver than I am. Ray's going to do a slightly different hack of a system, but he's going to do it real time, okay? I know mine will work. That's all I'll say, okay? Sorry, Ray. Okay, so a couple of demos. So I'm going to turn the volume up on this just to make sure it's... And this is what can happen if you have something poor on your system, okay? Now, I can only show you certain bits of this. I didn't want to show you the actual code or the bad SVC was there. We built this system to be poor, okay? We didn't, yeah, I wouldn't want to find this on a client system, but we do, okay? So here's the video. So, for the purposes of the demo, I'm going to use my own user ID logged onto the RSM demo system. So if you look at my user ID as it stands at the minute, it has all three attributes: special, operations and auditor. Yes. What we will do is remove those and then list my user ID again, and that user ID now has no attributes whatsoever. We will then log off and log back on. This is the point I didn't want to type my password wrong. And again, just to prove, here I have no attributes on the system. So if I attempt to issue a RACF command, so I want to give myself special, operations and auditor, RACF will fail that. Now if I have code on the system that is vulnerable, there is potential for me to develop an exploit. So I have one I prepared a little bit earlier, and here we have a very vaguely named member in a load library, Charlie 655321, and as you can see to the right here, it is link edited 00, which means it is not considered APF authorized. Even if this module was loaded from an APF authorized library, the fact that it's link edited AC0 rather than AC1 means ZOS will consider this module not authorized. So if I simply call it return code 0 and return back to my TSO command, list my user ID once again, that was just a little bit too fast, list my user ID once again, and you can see no attributes. Now if I attempt to give myself special, operations and auditor, and then do the LU, there we have special, operations and auditor. So what we can surmise from this little demonstration is, on this system there is a vulnerable piece of code that we have managed to develop an exploit for. Now all this code did was put itself into supervisor state, key 0, and then go and flip one bit in storage, essentially the bit in my ACEE that gave me the special flag in my current TSO address space. That allows me to issue the alt user command to write these three attributes to my user ID in the RACF database. So now when I log off and log back on, when I log back on, I no longer need to do any of that bit flipping, because I have picked up all of the attributes from the RACF database: special, operations and auditor. So effectively now I have the ability to give myself access to any resource on the system, whether that be dataset or general resource. If I haven't got access and it's a dataset resource plus a few others, I've got access to the data because of operations, and I've also got the auditor attribute that lets me disable audit functionality for all of the different profiles on the RACF database. So as you can see, a vulnerable piece of code is something that we would need to identify and remediate extremely quickly, because the risk posed to our ZOS systems is extremely high. Talks a lot, that bloke, doesn't he? So let me just step you through that again. Yeah, log on to TSO. You log on to this TSO with your RACF user ID and password. Part of that process, that rack init that takes place, generates that control block in storage, the ACEE. That's the bit that's got the flags that says you're Special Operations and Auditor. So when you issue a RACF command, RACF doesn't go and check the RACF database. It checks the contents of your ACEE in storage. So if you can manipulate those flags to fool RACF into thinking you've got a privilege in your address space that you haven't got on the RACF database, yeah, you can have some fun with this. So the ability to change that storage needs to be supervisor state. So if I can find some code that puts my running TSO address space into supervisor state, key 0, I can now change that flag in storage. So I only have to change one. I could have changed all three. I could have given that ACE in storage, Special Operations and Auditor. And there are two other really interesting ones in a RACF world, trusted and privileged. You can use those as well. But that's putting them up in this ACEE in storage. I've not written anything to the RACF database. So anything I do in this TSO address space or in a batch job that's doing all of this stuff, yeah, nothing's written to the RACF database. Because you're going to make some noise if you do this to the RACF database. So you might want to turn off some auditing things first and then write stuff to the RACF database. But once you've got that key 0 supervisor state, you really have got, you know, access to do whatever you want, whether you want to be noisy about it or whether you want to do it in stealth mode. Of course, now I've got special in the ACE. I issue a command that says I'm going to give Mark's user ID RACF special. It writes it to the RACF database. I'll log on and log back off. I've now got that attribute permanently. Now with special, I can give myself operations, I can give myself auditor, yeah? I can turn off all the auditing stuff, and I can go and have some fun with the system. Yeah? Write binary zeros all over your production DB2 database. That's okay, it's replicated. We'll recover from the replicated copy. Yeah. So this is what you're faced with when you have code vulnerability. So it's really, really paramount that you understand if you have any vulnerabilities on your system. Okay? And this, whilst this example here was a RACF one, yeah, it's the same for ACF2 and Top Secret. They work differently, but the principles are the same. So we had a little bit of fun with the Top Secret system a few weeks ago. And Top Secret has this user ACID, yeah, or user ID, called the MSCA, the Master Security Administrator. And that's the one that can issue all these fun commands to change your profiles in RACF. And yeah, there isn't a bit you can flip with that. But because we were key 0 supervisor state, we're actually able to create our own ACE, specifying the user ID of the Master Services, Master Security user ID, and then point our running address space at that ACEE. And do all of that in storage. So from that moment on, anything you do, you are now the Top Secret Security Administrator. And that's what people can get up to on your system if you have these kind of vulnerabilities. Okay? So we've taught, okay, Ray, this is you. So Ray's going to talk about this one now. Okay? So Ray's got a slightly different exploit to do. Okay? Fundamentally the same kind of thing. Yeah, we found some vulnerable code and we are going to exploit it. Okay? So at this moment we're going to try and do a quick technology refresh because Ray's brought his data center with him. Okay? I've got my sleek slimline Mac here. Excuse me while I step out of shot.
That's the new ZR1.
Yeah, that's a new ZR1. Yeah, yeah. So this thing here actually runs the Californian government, this one. This little laptop that Ray's got. So I'm going to leave it with Ray for a few minutes, and then we'll be back at the end.
Good morning. I'm going to try a little experiment today. How many people in the audience, how many people in the audience are systems programmers and are responsible for putting on maintenance on your systems. So we have some in here. Good. Do you have access to the security portal? Or access to the information from the security portal? In other words, where on your radar are integrity fixes, right? And are those fixes getting put on, or does the question of, gee, I don't know, I don't have enough information about them, I don't know what's going to break, and it's my butt when things break, so I don't put them on, right? If it's not broke, let's not fix it, right? I mean, when I do systems programming, that's the motto that we live under. So I'm going to say, I'm not going to explain it until the end, but classification equals clarity. Okay, so I want you to keep that in mind as we go through the quick demonstration here. Yeah. So this happens to be, I believe, a ZOS 2.2 system, fairly recent maintenance. I'm going to demonstrate a vulnerability exploit. It's based on a classification of the underlying vulnerability. So from that classification, regardless of what it is, I mean, it's what I call a storage alteration vulnerability. But understanding the classification should help you understand what the capabilities are and perhaps help with the clarity. With a storage alteration vulnerability, it's something where you can invoke a service and have the ability to pass an address and have that service updated for you, right? In a general way, it tells you how to exploit it, but it doesn't give you the specifics. You don't know what addresses to pass. You don't know necessarily what service it is. You don't know a lot of the other details that would be required to exploit it, but you do have a general understanding that, for instance, if the service is run in key 0, and soup state really doesn't matter for key 0, that it has the ability, directly or indirectly, to change any memory location that it wants to, right? And if you can control what address gets whacked and the data that goes into it, even better, right? So the classification of the vulnerabilities provides clarity. So in this case, we're going to dynamically elevate RACF security credentials, turn on the privilege attribute. Just to be equal opportunity here, I could turn on things in ACF2, such as security, non-cancel, read all. There's bits in the ACUCB that can turn off logging, et cetera, et cetera. So there are similar things that can happen in ACF2. Top secret rides along with the SAF interface and mimics quite a bit of what RACF does from an operational standpoint, right? They have ACEEs, in memory anyways, and you have to twiddle a couple extra bits, but turning on privilege for top secret works just fine, right? So this concept of a storage alteration vulnerability, I think, provides clarity into what the capabilities are of any type of storage alteration vulnerability, right? So I'm going to go through a quick little demo here. I'm going to try to get access to my well-named data set, noaccess.testdsn. Nobody ever likes my names, so I get that. The security system is RACF, but like I said, ACF2 and Top Secret have the same issues. And so I have a violation, and let's say that's my encryption keys, and I really, really, really need access to them for whatever reason. I'm going to use TSO test to execute a little program. Test by design won't let me do APF authorized things. I can't be set code AC1, I can't be in the APF list. It falls over. So I execute it. I put a couple of nice messages in there so when I know I'm having a good day or when I'm having a bad day. It worked. I'm going to exit. And now I'm going to retry my edit, and now I have access to my whatever it is that I was, whatever my target was. So back to my experiment about classification is clarity. If you had the information that said, gee, this is a storage alteration type vulnerability, and had some nomenclature in there that said, gee, you can control the address that gets modified and you can control the data that gets set. Is that enough information for the systems programming staff now, without detailed exploit information, for you to decide, gee, maybe I should get that fixed. I don't want my end users to be able to bypass the controls that ZOS and the ESM is, that we've put in place. That's a bad thing, right? So something I want you to think about, and maybe there's different ways to do this, certainly the classifications and how that would happen, but I submit to you that when I talk to people about vulnerabilities, both on the development side and the end user side, the management, the risk people, when I put it in terms of classifications and what the capabilities of that class of vulnerabilities has, that the conversation gets much more clear. People understand. People can make decisions. It's not this ambiguous cloud saying, oh, I have this integrity error. I have no idea specifically what it does. And that's even over and above the CVSS scoring. Most mainframe people don't know much about the CVSS scoring. You're going to need to learn. There's a version 2 calculator. There's a version 3 calculator. If you're new to it, I would start with a version 3. The way I score this type of vulnerability is by classification, and we would give it somewhere in the 8.6 range. Now, Mark talked a little bit about the CVSS score. The way I like to explain it, it's sort of like the Richter scale, right? A 5.0 earthquake might shake you and wake you up, might knock some glasses off. If it's in the 8 range, the house is down around your ears, right? It's very exponentially, as it gets closer to its high value, it gets exponentially worse. Based on conversations I've had with people in the field, pretty much if it's on the other platforms, if it's 7 and above, they pretty much stop what they're doing, and sometimes they can't go home until they get it remediated, right? So very, very serious. So the CVSS score is very important, and there's a bit of detail. You could spend a couple hours getting a pretty good idea of how the calculator works and how they come up with their numbers. But I think the classification is the piece that we may be missing that would help the people doing the work, the systems programming staff as well as their management, to decide, hey, I see these integrity vulnerabilities. They're coming in on the portal. They should be coming back into your systems programming staff, and what are we going to do about it? This should be on your radar, right? If you wait until you have the problem, it's too late, right? So policies and procedures you have to have in place, but management and the people and the systems programming staff, the technical people, they have to have enough information to be able to make intelligent decisions for your company. Do we put this on? And I find in most cases, unless there's this additional information of clarification, or classification, sorry, that it sometimes doesn't happen, or at least without an incident being associated with it. So, any questions? I do have one question. My experiment today was to see and get some feedback for integrity-based code vulnerabilities. Do you think classification would help you in your job to do your thing? And I have people raising their hands. It's good, but it's something to think about, and there's an ongoing discussion about this, and I think having an informed opinion and letting the vendors know your opinion is a good thing. There may be disagreement, but eventually I think people can get together and do that, but without your participation, that can't happen. So, thank you.
Turning on, that's better. So, just to try and wrap all this up, yeah, and tie these bits together. Yeah, if you have these code vulnerabilities and you've seen the kind of stuff that Ray and I purport to be able to do, this is a problem for us, yeah, and they exist, yeah, most of the time by accident. Not many people today, yeah, write a piece of code and say, I'm going to write it really badly, unless his name's Chad, but that's, yeah. Okay. Because Chad just does that to me just to wind me up every now and then, okay? So, what we need to be doing, yeah, on our systems is scanning these systems for these code vulnerabilities, looking for them, checking for them, okay? But the thing is, it's not a one-off exercise. You actually need to bake this in to your mainframe maintenance cycle, your change management process. Yeah? And do you scan all of your software when you apply a couple of PTFs? No. But when you do a ZOS, okay, I'll concede. When you do a ZOS upgrade, yeah, should you be doing it? Absolutely. Yeah? Do you put RSU maintenance on a couple of times a year? Once you've done that, you should be scanning the code, because a fix can actually introduce a problem. Yeah? Don't necessarily trust the fact that it's a fix, it's going to fix that problem and not cause another one. It could. Yeah? So you need to start thinking about this. Where do you do the scan? Do you do it in your systems programming LPAR? Do you do it in your dev LPAR? Do you do it in your pre-prod LPAR? Do you do it in production? But one of the things we have to contend with is a lot of software products these days dynamically load stuff. They might dynamically load an SVC or a PC routine. If the piece of software is not running on the LPAR, we may not see it, we may not find it. So you've got to make sure all this stuff's running. So a good place to run this kind of vulnerability scanning type testing is in a DR environment, a real clone, yeah, network isolated, copy of production, everything up and running, and then throw this stuff at it, because it's quite entertaining what it does to your system when things can go wrong. Yeah, you are the non-mainframers, when they talk about this type of vulnerability scanning, they talk about fuzzing. Yeah, and basically what you're doing is you're throwing stuff at pieces of software and seeing how it reacts. Yeah. Well, I know this SVC takes a parameter. What if I buffer overflow it? What about if I send it this and it's not written to cope with this? Yeah, all that type of stuff. Yeah, things go wrong. Yeah, pieces of software sometimes react badly to being asked the wrong kind of question. Yeah, SVC 34. Anybody know what it does? Commands. Yeah, what happens if you disable SVC 34? Yeah. Or break SVC 34. It's very difficult to shut down anything or start anything. So what do you have to do? IPL. Yeah? Not really something you want to be doing on your production system at midday on a Wednesday. Or a Monday, Tuesday, Thursday or Friday. Okay? But that's the type of thing. Yeah? So this is what I'm saying here is each time you make mass changes to your software stack, yeah, whether it's IBM supplied, ISV supplied, or your systems programmer said, I've rewritten that SVC to make it more secure. Are you sure they actually have? Yeah. So this is the type of thing you need to be done. Yeah. It really does need to be baked into your change management process and procedures. Yeah? You shouldn't be putting a new version of ZOS or Kix or DB2 or IMS Live without having done some of this stuff. Okay? Reread the previous slide. Yeah? That's what we need to be doing. Okay? We have to take this seriously because one of the things I say to people is, if people like Chad and I who do this, I'd like to say Monday to Friday, 9 till 5, but it feels like more like, Saturday evening through to Sunday morning, 18 days a week, 29 hours a day type thing, yeah. We are not at this all of the time. We've got day jobs, yeah. But you look at those folks out there who are financially motivated, politically motivated. They are going to knock on our door at some point, yeah. If you believe the marketing hype from IBM, yeah, the mainframe holds 70 or 80% of the world's commercial data, 70 or 80% of all the commercially running code. Where do you think they're going to go looking for all the good stuff? Yeah? Ray's data center, yeah, here, or your mainframe. And if they can spot this stuff, yeah, because we can, if they can spot this stuff, they could have some fun, okay? Absolutely sign up to the IBM security portal, okay? Go and deal with the folks in Poughkeepsie, send them an email and get registered, and have in your mind a diarised check of the portal of anything new that comes out. Because you need to be aware of this stuff coming out. It can be a little bit challenging sometimes to work out whether, do I need to apply this or don't I? But some information's better than none, okay? And get yourself to the point that you're on the front foot. And check your own code. If you've written anything yourself and you look through your marks.asm.lib and I look at a piece of code that I wrote in 2009 and I look, oh, geez, did I really do that? And I think to myself, oh, there's a client who's still running that back in the UK somewhere and I'm sure that's on production. So write them a little email and you might want to use this one. Hi Mark, lovely to hear from you. Do we still run that code? Yeah. Just check your own stuff. This is not just about IBM and the vendors. Check the own stuff that the systems programmers are writing. Yeah. And ask your vendors if they've had their code tested. Yeah. Do they know that it's actually secure? Have they tested it? Have they checked it? Yeah. We have a little bit of a story with one vendor that we've mentioned, here's a problem with the code. And they came back and said, working as designed. Yeah. And this is a piece of code that literally had every key to the kingdom you want. Yeah? I can call it with a certain parameter and it puts you into supervisor state. I can call it with a different parameter and it says branch to this piece of storage and execute the code that's there. And you can call it with another parameter that says put me back in problem state. Yeah? These are all the things that are out there. Yeah? So you've got to be careful. Okay? Anybody got any questions? Who's going to go back and start checking their stuff? You should. So, got a little bit of fun just to finish off. Okay. Who knows what this one means? Yeah. Problem exists between keyboard and chair. Yeah. Now, somebody who's going to come into your organisation and possibly exploit a vulnerability is not going to be Chad here, the problem between the keyboard and the chair, okay? He's going to be somebody who's really, really motivated and know what he's doing. But, yeah, people can accidentally stumble on things, so we've got to be careful of that, yeah? Now, I'm sure most of you have seen the Jimmy Kimmel videos, yeah? This is who's not seen the Jimmy Kimmel video?
Of their information than ever. President Obama.
So this is where they walk down the street and shove a microphone in front of somebody and say, will you tell me your password? Okay? The alarming thing with this video is they have a 100% success rate. Everybody they talk to gives them their password. And it's not difficult. The interesting thing for me is they actually did another one. And this one was 100% successful.
They may have compromised.
So when you
the
think about
information of 140
our
million
users and our
Americans, which is a
systems
lot of
having
Americans.
vulnerable
So in light
code
of
and
this,
poorly
as a service to the
misconfigured
public,
and not
we've
secured
actually done this
properly,
before, and it's
yeah?
very effective.
I know
We
all
asked
you lot
people
wouldn't
who
do
are
any
passing
of
by
this
our theater
stuff.
today what
Yeah?
password they
But
use to
Chad,
protect their personal information.
that's a different story.
And pay attention,
Yeah?
please, because there are
Yeah?
a lot
Or
of
Lou. Lou
important
wouldn't give
tips to
anybody
be
his
shared
password.
here.
Now, John might.
We are talking to people about the cybersecurity
3 o'clock in the
breach
morning in the bar, John's, what's your password? How
we're asking
much?
people how
Yeah?
secure their internet
But,
passwords
yeah,
are. What do you use
these
for an
people
internet
here are
password?
being interviewed on a public street
You know, I usually
and being
stick to
asked
my
for their
last
password.
name. That's probably not the best thing to do, but I usually stick to my last name, a few digits, maybe like a hashtag or something, or
How do you spell your last name?
Walker.
Walker?
Yeah,
W-A-L-K-E-R?
yeah,
And then just a few numbers?
I probably should have told you
And
that.
then a
but
hashtag.
yeah,
Okay.
yeah.
The numbers, like, what do you use? Like your birthday or something? Your area code?
Yeah. Usually like my birthday,
How old are you?
21.
21? What day you born?
November. No, the day. Sorry, the 29th.
29th of November?
Yeah.
So these videos are all out on YouTube. You can just go to YouTube and just search Jimmy Kimmel password and you'll find them. They are hilarious. This one I think is a little crueler than the other one because there's rather an unfortunate looking gentleman who comes on and what do you do in your day? Yeah, answers a few questions and the journalist with the microphone turned around and said, and you scare small children. And he just completely missed it. Just went straight over his head. They invite him to the studio at the end of this and he's on and everything. But my point is, when we do these kind of talks, we talk to the converted. You folks all know what you're doing. But when we've got users like this of our system, this could be a person who walks into your organisation on a Monday morning and logs onto your system. TSO, KICS, IMS, DB2. He could be using the stuff you're trying to protect. And if I've left some dodgy code on your system, they may accidentally stumble on it. He'll have no clue what he's doing, but they may accidentally stumble across it. Okay. So, we've got a few minutes. We've got 5 minutes for questions. Anybody got any questions? We're quite happy to stand and chat. It's a little early to go to the bar just yet, but yeah. Stranger things have been done, but there we go, yeah. Shh. Don't tell them where we were before we got here. Anybody got any questions? Paul, it's all yours.
Okay. All right. Well, listen, thank you very much.